Good day, everyone. It's Mr. Weave here. We're going to be starting our extended period of e-learning by actually jumping ahead a little bit into the chapter on area in chapter 10. We're going to jump right ahead to section 6 and start talking about the study of circles and arcs today. So our main objective is to define some vocabulary and then get you going measuring arcs today. So I want you to look at the diagram of the circle first, and we're just going to make a note of a couple of the definitions here. First, how we name a circle is always going to be by marking the center point, and then we use this symbol right here. It's got a little, like literally a picture of a circle with the center marked, and then the name of the center point. So in this diagram, point P is the center, and so we would call this circle P. Number of line segments drawn in the circle. One of them goes straight across and goes through the center point, and we call that a diameter. So AB, the blue segment, would be a diameter. If I go straight from the center point to the edge only, that makes that half of a diameter, and we call that a radius. I'm pretty sure you have seen those two terms before. Of course, P here is the center point. Highlight it there. Now there are some angles in this picture too where these segments come together, specifically at the center point. So I have an angle here, APC, where P is the vertex, and that, because the vertex is at the center, we call that a central angle. Easy to remember because the word central kind of reminds me of the center. The vertex of the angle is at the center of the circle. So some of the questions at the bottom was, what is the name of another central angle? Well, the one that's marked with purple here, APC, is one of them, but any angle formed by two radiuses touching at the point P would be a central angle. So for example, B to P and then P to C, this angle right in here would also be a central angle, so I will name that BPC. Question 2, what is the name of another radius? Well, again, any segment connecting the center point to the perimeter is a radius. So I could take the two halves of this diameter and call them a radius. So from P to A would be one, or you could call it AP, and then from B to P is also, or P to B is also a radius. Let's now look at the perimeter of the circle and notice that if I mark some points on the perimeter, I can actually divide the perimeter or circumference into smaller sections, and we call those sections of the circle arcs. There's really three classifications. Either an arc is exactly half of a circle, in which we call it a semicircle, and the way you can tell is if I were to draw a line segment connecting these 2 points here, I can tell that that's a diameter T to R, and that way the arc of the circle that goes from T to R along the top would be a semicircle. Any arc that is less than halfway or smaller than a semicircle is called a minor arc. So this red arc here that goes from R to S would be a minor arc. One of the questions at the bottom is, what would be the name of another minor arc? Well, if you take a look from S to T, that's also less than half of the circle. So if I use the letters S and T or T and S, and I think you already noticed the little notation here, we're putting a little arch over top of the letters to indicate that is an arc on a circle as opposed to a line segment or a line. If an arc is more than halfway, or in other words, bigger than a semicircle, it's a major arc. So I can see that if I were to go from R to S, but go the long way around, it becomes more than halfway. And so now you notice I can go from R to S 2 different ways. So in order to designate the major arc, I use another point to specify that I'm going to go through there before I go to S. So if I go from R to T to S, or from S to T to R, that is a major arc, and the T in the middle tells us that we're going to have to go through T on the way to R. So another major arc might be if I wanted to go from T to S, but go the long way. So as opposed to the short way, TS, which is the minor arc, if I go the long way around and go through R first, I could call it TRS and then arch across all of them, and that is definitely a major arc. It's more than halfway around. So let's just look at this example and notice circle O, and let's notice that all four of these arcs are minor arcs. They all are less than half the circle. AD is right here. CE is right here. It's the arc right along here. AC is going to be the arc along the top. And DE is the one along the bottom. And all four of those arcs make up less than half of a circle. So they're all minor arcs. Let's notice that all four of these arcs are semicircles. In other words, they're exactly halfway around. One is ACE, so if I start at A, end at E, and go through C, that's halfway around this way. And then EDA is along the bottom. EDA this way is also a semicircle. And then I've got DAC, so starting at D, ending at C, but going through A to get there would be a semicircle along this side. And CED, starting at C, ending at D, but going through E to get there, that's also a semicircle because CD is a diameter. Let's finally point out that all four of these are major arcs. In other words, they're longer than halfway around. So A, C to D. It's arc from A to D, but I go through C. So that's the long way around, all the way around there. CEA is C to E to A. That goes around the bottom. That's more than halfway. EDC, E to D to C. That's the long way around this way. And DAE, starting at D, ending at E, but going through A to get there. And I also could have called, by the way, I could have also called that one DCE instead of DAE. That's the same location. Those are all major arcs. So let's get one here for ourselves that we have to answer ourselves. In fact, I encourage you to pause the video at this point and just try and look at this diagram yourself for a minute. It says, what are the minor arcs of circle A? There's more than one answer to this. I encourage you to pause the video here and take a look at this yourself first. Okay, let's answer the question. What are the minor arcs of circle A? Any arc that goes less than halfway counts. So let's see if I can name a few that start with S. Well, I could go from S to R, or call it RS. If I went from S to P, that would be a minor arc. If I went from S to Q this way around the top, that would also be one. Now, to specify, I'm going to call that one SPQ to make sure we know we're going to go this part of the way, not the long way. Maybe you can look at this and name a few more. For example, just PQ itself is another one. Okay. Finally today, let's talk about how we measure angles and arcs. We know how we measure angles. For example, we know that an angle that would be basically a quarter of a circle would be 90 degrees. And so if I draw an angle at the center, we could measure it in degrees as well. So the angle I've got here, the central angle S, or angle RST, is said to be 50 degrees. Now, if I were to divide this into multiple central angles, I would draw other ones in here and have lots of different central angles. One thing we know is that if I added all the measurements together, I'm just going to put dots in there to indicate where the central angles are. One of them right now is 50, but if I were to measure all the other central angles and add their measurements together, we know that the combined total is 360 degrees. So that way, if I were to find the measure of the other angles, maybe some other angles in here, like this really long angle going around the outside, I know that it's going to be 360 subtracted by whatever the other angle is, which is 50. Now, the definition we're making today is that arcs can also be measured in degrees. And this is very easy to do. If I have a central angle that opens up and touches the circle at the 2 points of the arc. So, for example, this arc RT, the measurement will be the same as whatever the measure of the corresponding central angle is. So if angle RST is 50 degrees, that means this arc RT is also going to be called 50 degrees. And that gives us a way to measure the major arc that goes all the way around from R to Q to T. And that is to take the entire circle, which we will call 360 degrees, and simply subtract 50. And so that way, this major arc that goes all the way around to the outside here is actually going to be 310 degrees. That gives us the 360 total. So one theorem before we go to an example, one theorem that may help today is that I know that if I'm adding multiple arcs that join together, we can just add their arcs together to make a larger one. This is very similar to adding segments together if they're all in a straight line. So for example, the arc from A to B, let's just put some numbers to it. Let's say this arc here was 35 degrees. And then from B to C, let's say that was 80 degrees. Now I'd be able to measure the arc that goes A, B, C, and just by adding those together. And so I could do that by adding 35 degrees from AB and the 80 degrees from BC, and I think that's going to give us 115 degrees total, which is the sum total of these two arcs right here. So our example today is to look at this picture, looking at the two arcs or two angles or arcs that are given, and let's try and find the measure of these arcs. First is arc BC. BC is this arc that's right in here. And so to find it, all we have to do is look at the corresponding central angle, and the angle BOC is 32 degrees, so that makes that the angle, the measure of that arc. Part B is the measure of arc BD. So BD now starts at B and it goes to D. So now that I know that this one was 32 and that C to D was 58, all I'm just going to do is add those together. And notice that that makes 90 degrees. Problem C, what's the measure of arc ABC? So now that's specifying to go from A to B to C. That's all the way around here. Now what I'm noticing this time is that AC is actually a diameter, which that means that this arc around here is exactly half of the entire circle. So I don't have to do anything but know that's half of 360, so that'll be 180 degrees. Finally, arc AB, which starts at A, winds around here just to B. So what I'm going to notice this time is we already figured out that arc ABC was a semicircle, or 180 degrees. And now to get AB, I'm really just going to cut out the 30 degrees. And so how I'm going to get this one is to take the semicircle ABC and just subtract 32 degrees. And that's going to give me a grand total of 148 degrees.